Activity 3, 5.3, transformations of a segment. This activity is actually on rotations of this segment in a coordinate plane. So activity 5.1 was on translation, activity 5.2 was on reflections, and this activity 5.3 is actually on rotations. So what you have to do is rotate this line segment around 3 different centers of rotation 90 degrees, either clockwise or counterclockwise. So the first one is rotating this line segment around B as the center of rotation, counterclockwise. It's going to go this way, so it's going to end up down here somewhere. The second one is rotation of this line segment around a center of rotation at point A, again counterclockwise. So it's going to swing up over here somewhere. And the last one is a rotation of this line segment around the origin, around 0, 0 right here, clockwise. So it's going to swing down this way in some fashion. So actually here are those rotations. It's hard to look at. So what I did is I added some color so you could see the triangles and we could talk about the movement of those triangles. So the first one is a rotation of this pink triangle around point B counterclockwise, so it's going to end up covering the blue triangle. So this line segment is going to go to its corresponding side of the triangle, and it's going to end up right here. So it's a 90-degree rotation, and so to figure out the placement of that line segment, you can count. So if you're at B as the center of rotation, and if you count, if you're going to rotate 90 degrees, you can count up 1 unit, and in the direction of rotation 1, 2, 3, 4 units. And then you rotate this down 90 degrees, and you count from B, you count up 1 unit in this direction, and in the direction of rotation 1, 2, 3, 4. And you end up at that point right there. So that is a 90-degree rotation. The next one is a rotation around A, again counterclockwise. So you can go from this line segment, it's going to rotate around A and end up covering the red triangle, and its corresponding side is this line segment right here. So again, you can count from A now. So I'm going to count down 1 unit, and to the right 1, 2, 3, 4 to get to B. And so then I'm going to rotate. So now I'm going to rotate up from here. I'm going to rotate up 90 degrees to right here. I'm going to count 1 unit this direction, and then 4 units up. 1, 2, 3, 4. And you end up where D is. So that is a 90-degree rotation, counterclockwise. And the last one is a 90-degree clockwise rotation, with the center of rotation being the origin of the coordinate plane. So now you're going to rotate this line segment, and it's going to rotate down to here, right here. So if I start at this point and I count up this axis 3 units, 1, 2, 3 to get to A. So now I'm going to rotate 90 degrees, and I'm going to count 3 units along this axis, a 90-degree rotation. And so point A is going to go to this spot, its corresponding point. Point B, I'm going to count up 2 units, and then 1, 2, 3, 4 units in the direction of rotation. So I'm going to rotate this 90 degrees. So I counted up this way, so I'm going to rotate this way. I'm going to count over 2 units, 1, 2, and then 1, 2, 3, 4 in the direction of rotation. So point B is going to land right there. And so let's focus in a little bit on that last rotation. So this is a 90-degree rotation. So again, AB is going to rotate around this center of rotation. It's going to rotate around here, and it's going to land right here. So count up 3 units, 1, 2, 3, and count along this axis, rotate 90 degrees. Count along this axis, 1, 2, 3 units. And so A is going to go to point E. And then where does point B go? Well, count up this axis, 1, 2 units, and then to the right, 1, 2, 3, 4 units. Now rotate 90 degrees, and then count 1, 2 units along the axis, and then 1, 2, 3, 4 in the direction of rotation, and B moves to its corresponding point, which is F, after the rotation. And so let's watch a little video of this. I'm going to take that triangle, move it over. In the first case, I'm going to rotate it around point B as the center of rotation. So there it goes. I'm doing all of this in Docere. You can do the same thing in Docere. Rotate it around, and it lands on its rotated triangle. Now I'm going to rotate it around point A, again counterclockwise. So there it goes around point A. All right. So let's look at this in a little bit more detail. What I did here is I took away the grid. The grid is just a lot of stuff to look at. So to remove some of that stuff to make it a little bit simpler to look at, I removed the grid, although you do lose those points to use to tell where you are. But I added 2 more centers of rotation. This red point right here. So now line segment AB is going to rotate around this red point 90 degrees, and it's going to land right here. And so we're going to look at this in more detail in a moment. And I also added this purple point as a center of rotation. And so now AB is going to rotate clockwise and land right here. So it's going to rotate 90 degrees this way. It's going to rotate around here and end up covering this line segment right here. So to see that in more detail, I added some circles. So the first one, this is the center of rotation. This is point A, and A is going to rotate 90 degrees to this point right here. Now both of those points have to be on the same circle. It is that point moving through this distance on the circle. It's the same distance from the center of rotation, and it's going to end up right here after a 90-degree rotation. B is going to do the same thing, but it's going to move on this smaller circle. It has to have the same center of rotation, but the path is different. It's on a smaller circle, and so there it is. And B is going to move from this point and rotate around and land right here after a 90-degree rotation around this as the center of rotation. Keep looking at these things and you keep trying to do these problems, it will begin to make sense to you. This is not easy. All right, let's look at the other center of rotation, this one. And so point A is going to rotate around this center of rotation and end up right here. And you can see that 90-degree angle, and you can almost visualize the circle right here. I'm going to show you those circles in a moment. And B is going to start right here, and it's going to rotate around here and end up at this point right here, 90 degrees in a counterclockwise direction. So if I add those circles, you can see that A rotates through this circle and ends up right here. It is the same distance from the center of rotation. It has to be. It is on that circle. And B is on the larger circle, and it rotates from right here through 90 degrees and ends up right here. All right, so let's look at this in a little bit more detail. So I included the arrows. So this is the 90-degree rotation of A in the smaller circle. This is the 90-degree rotation of B in the larger circle. And this green line segment, this is AB, is going to move through the coordinate plane until it lands right here after a 90-degree rotation. So I'm going to step through that so that you can see it. So as it rotates through, both A and B are rotating 90 degrees. and they end up, after they both rotate 90 degrees, they end up right here. So let's watch a little video of that. And so here it goes. Now notice that A travels a shorter distance than B, but they both travel for the same amount of time. So which one's traveling faster, A or B? And that would be a higher level mathematics that you would get into in later years. But B has to be traveling faster. It's moving a longer distance in the same amount of time. All right, so that's a rotation of the line segment AB, a 90-degree rotation. And so point A rotates 90 degrees, point B rotates 90 degrees, and the whole line segment ends up rotated 90 degrees. So what do they want you to conclude? If you do a 90-degree rotation, wherever that center of rotation is, so whether it's A, B, this point right here, the origin, this point right here, this red point, or this point right here, this purple point, whether you rotate counterclockwise or whether you rotate clockwise, all of these line segments are parallel to each other. They're all 90-degree rotations of this line segment, but wherever they are in space, now they're different places because they have different centers of rotation, but they all have to end up parallel to each other, whether it's a rotation counterclockwise or a rotation clockwise. So these are rotations of points, line segments within a coordinate plane, coordinate grid.